Welcome back, students. Today is session number 9 from the chapter of laws of motion, and this session is in continuation of the session number 8. In this session, I will be discussing a couple of configurations with regards to the system of two or three blocks. So, here in this session, we will be discussing the motion of the connected bodies, and in this means on the this board, I have taken up one case in which a force F is applied to a block of mass M, and these two blocks are in contact with each other. So, in this case, we have to find the common acceleration of this system of two blocks, and we have to find the force at the common interface. That is, common interface is this. This is the common interface. Okay, or you can say the common contact area. This is the common contact area of the block having a mass m1 and this block having a mass m2. So this is a system of two blocks, and a force F is applied on the block having a mass m1. Now the common acceleration is very easy. It is very easy to find the common acceleration because as we know that force is equal to mass into acceleration. So it implies that acceleration will be equal to force upon mass. Now in this case, since these two bodies are moving together, when the force F is applied on the block having a mass m, then the common acceleration जो है that will be given by common acceleration will be equal to the force applied divided by the total mass, and the total mass is equal to m1 plus m2. So this is the common acceleration of the system of two blocks when a force F is applied to the block having a mass m. Now the second point is when this system of two blocks starts moving with the common acceleration, let us say it is A is equal to A. Okay, I am just say this common acceleration is equal to A, and which is equal to F divided by m1 plus m2, where m1 and m2 are the mass of this block that is denoted by A, and that is denoted by B. So where m1 and m2 are the mass of this block A and block B. Okay. So when the common acceleration is equal to A, then see here the force is applied on the block having a mass m1. So the force, we can say the force consumed by the block A कितना हो जाएगा? फोर्स इज इक्वल टू मास इनटू एक्सेलरेशन. मास कितना है इसका? m1 है, m1 है, एंड व्हाट इज द एक्सेलरेशन? दिस इज द एक्सेलरेशन. ठीक है, दैट इज m1f divided by m1 plus m2. So this is the amount of the force which will be consumed by the block A when a force F is applied to it, and this force basically is imparting this common acceleration A to this mass m. So when this mass m moves with an acceleration A, which is given by F divided by m1 plus m2, then the force which will be consumed by this block A will be equal to, that is mass into this acceleration, which is equal to m1 dot f divided by m1 plus m2. ठीक है? This is the second important point. We have calculated the common acceleration. We have also calculated the force which is consumed by the block A. Now, when here the force applied is equal to F. The force which is consumed by this block A is equal to this one. So the remaining force, it will be transferred through this contact surface. The remaining force will be transferred through this contact surface to the block B having a mass m2. So we can write here as the force transferred to the block B through this contact surface. Contact surface will be equal to F, that is the force applied, minus the force which is consumed by this block A, which is equal to F m1 minus F m1 divided by m1 plus m2. Or it can be written as, or it will be equal to, if I just take the LCM, I will get it as m1 plus m2, and it will be F m1 plus F m2 minus F m1. So finally we will be getting as F m2. Okay, so the force acting at this contact surface or at the interface of this block A and B will be equal to F into m2 divided by m1 plus m2. Okay, so this is how we can calculate the common acceleration and the force at the common contact surface of these two blocks, or we can say we can calculate the force at the interface at the common interface of block A and block B. तो ये हो गया, that is the force at the contact surface of A and B will be equal to F into m2 divided by m1 plus m2 in this case. ठीक है, so common acceleration निकाल लिया. We have also calculated that how much of force will be consumed by the block A, how much of the force will be transferred to the block B. ठीक है, so this is the amount of the force which will be transferred to the block B. Since or in other words, since this force is getting transferred to the block B through this contact surface, that is the contact interface between this block A and block B. So we can say that the force at the common contact surface will be equal to F dot m2 divided by m1 plus m2, and these were the two important things which we were supposed to find out in this system of two blocks. So now I will be taking one more example. Now let us take the case of a case, or you can say a system of 3 blocks. एक ऐसा है, ये एक मान लीजिए ब्लॉक है. This is a block, say A. Let us say this is a block B, and this is the block C. ठीक है, और इसका हम ले लेते हैं मास m1, इसका ले लेते हैं m2 और इसका ले लेते हैं m3. ठीक है. Now I am applying a force F from here. ठीक है. So this is the this is the common interface of the block A and B, and this is the common interface of the block B and C. ठीक है. Now I am applying a force F from this direction, and this force is being applied to the block of mass M. So in this case, what will be the common acceleration? अच्छा, इसमें एक चीज है, इसमें एक जो पॉइंट मैं बताना भूल गया था कि दिस इज ए फ्रिक्शनलेस सरफेस. Here we are not considering the this force of friction, because this is the frictionless surface. ठीक है. So because this is a frictionless surface, so the force of friction will not come into play. So the common acceleration in this case would be equal to force applied divided by m1 plus m2 plus m3. ये हो गया मेरा कॉमन एक्सेलरेशन. दैट इज, लेट अस से दिस इज इक्वल टू a. So this is the acceleration with which these three bodies, or you can say the blocks, will move. Means this is the acceleration with which these three blocks will move together. ये एक साथ मूव करेंगे and their common acceleration will be equal to, that is f divided by m1 plus m2 plus m3. ठीक है. So now अब इस केस में हमें अगर हमको निकालना है कि what will be the force at the interface of this A and B and the interface of B and C. So ये force यहाँ पे सेम कॉन्सेप्ट हम यूज करके, जो भी अब मैंने प्रीवियस एग्जाम्पल में बताया था कि द फोर्स कंज्यूम्ड बाई ए कितना हो जाएगा, बाई ए इट विल बी इक्वल टू, इसका कॉमन एक्सेलरेशन आ गया मेरा, दिस इज इक्वल, इसका मास कितना है m1 है, तो फोर्स कंज्यूम्ड बाई ए विल बी इक्वल टू f, ये एक्सेलरेशन हो जाएगा, इनटू m1 divided by m1 plus m2 plus m3. ठीक है. The remaining force will be transferred to this block through this interface, that is the interface of block A and block B. So remaining force, I am just writing it here also, remaining force will be transferred to the block B. ठीक है. Remaining force will be transferred to the block B through the common interface and through the common interface which will be given, and through the common interface, and will be equal to फोर्स अप्लाइड कितना है, एफ है, माइनस हो जाएगा ये, दिस इज द फोर्स विच इज कंज्यूम्ड बाय ए. नो, दिस फोर्स विल बी कंज्यूम्ड बाय ए बिकॉज this is a system of three blocks and they are moving with the common acceleration a. So when now each of these blocks will be moving with the common acceleration a. So since these blocks are moving with a कॉमन एक्सेलरेशन ए, सो इसका ए का भी एक्सेलरेशन ए होगा, बी का भी होगा सेम वही ए होगा, एंड सी का भी सेम वही होगा. So when since this block A is moving with an acceleration A, so the force which will be consumed will be equal to, that is acceleration into this is the acceleration, that is F divided by m1 plus m2 plus m3 into the mass, that is m1. So the remaining force क्या होगा? It will be transferred to this body, that is the block B, through this common interface. ठीक है, and this will be equal to F minus, ये हो जाएगा F m1 divided by m1 plus m2 plus m3. ठीक है. So now I will solve this equation here, and I will be writing this equation. Now I will just write it here, that is the force consumed by A, that is यहाँ, अब यहाँ लिख देता हूँ, force consumed by A by A, this is equal to F dot m1 divided by m1 plus m2 plus m3. ठीक है. Now I will, इसको मैं मिटा देता हूँ, and now I will, so the remaining force which will be transferred to the block B through the common interface will be equal to, ये हो गया, which is equal to, or we can say is equal to क्या हो जाएगा, इसका हम LCM लेंगे, so it will be F m1, ये माइनस हो जाएगा, and the remaining what will be F m2 plus F m3. So it will be F m2 plus m3 divided by m1 plus m2 plus m3. ठीक है. I got this this value from this you can say this equation. So ये आपका हो जाएगा, that is equal to F m2 plus F m3. So I have taken F as a common. So this is the, you can say, the force at the interface of A and B blocks. ठीक है. So this is the force which will be acting at the interface of this block A and block B, and this is the force which will be transferred to the block B. It will be transferred to the block B, and so now I will write this. That is मैं यहाँ लिख लेता हूँ, that is the force at the interface of A and B. यहाँ लिख लेता हूँ मैं, force at the interface of A and B. ये हो जाएगा आपका F m2 plus m3 divided by m1 plus m2 plus m3. ठीक है. Now see, now what will be the amount of force which will be consumed by the block B? Since this is a system of block which is moving together with a common acceleration A, so the force which will be consumed by block A, force consumed by block block B, this will be equal to what? You know, this is the force consumed by the block B will be equal to the mass into acceleration. The acceleration क्या है? ये हो गया F m1 डिवाइड बाई m1 प्लस m2 प्लस m3 इंटू द मास, ये हो गया। तो ये हो जाएगा f डॉट m2 डिवाइडेड बाई m1 प्लस m2 प्लस m3। ठीक है। अब आपसे ये पूछा जा सकता है कि व्हाट विल बी दी फोर्स एट द इंटरफेस ऑफ द ब्लॉक बी एंड सी। तो भैया ये जो फोर्स जो इस ब्लॉक बी पे ट्रांसफर हुई है वो ये है, एंड द फोर्स विच इज बीइंग कंज्यूम्ड बाय द ब्लॉक बी इज दिस वन। सो द नॉट द रिमेनिंग फोर्स, इन दोनों का जो डिफरेंस होगा, दैट विल बी ट्रांसफर टू द ब्लॉक सी थ्रू दिस common interface. So we can say that force at the interface of B and C, it will be equal to this minus this. So this will be equal to F m1, sorry, this will be f m not m1, this is m2 plus m3 divided by m1 plus m2 plus m3। ठीक है। This was the force at the interface of A and B. So this force is getting transferred to this block B. Now the block B will consume a force which will be given by this value, that is this is f divided by m1 plus m2 plus m3 is the common acceleration, the acceleration into its mass। ठीक है, ये हो जाएगा आपका, ये वैल्यू आ जाती है। नाउ ये कंज्यूम हो गया, सो द रिमेनिंग की जो फोर्स है दैट इज दिस माइनस दिस विल बी ट्रांसफर्ड थ्रू द इंटरफेस ऑफ बी एंड सी टू द ब्लॉक सी। सो द फोर्स एट द इंटरफेस ऑफ बी एंड सी विल बी इक्वल टू दिस माइनस दिस। ये हो जाएगा आपका f डॉट m2 डिवाइडेड बाई m1 प्लस m2 प्लस m3। ठीक है, ये आ गया। और सिंपली हम इसको लिख सकते हैं, ये एलसीएम हो जाएगा हमारा m1 प्लस m2 प्लस m3। ये मैं यहाँ पे लिख लेता हूँ, m1 प्लस m2 प्लस m3 हो गया, और ये होगा fm2 प्लस fm3, और ये माइनस fm2, तो ये fm2 हट जाएगा। सो वी विल बी गेटिंग एज f डॉट m3। सो द फोर्स एट द इंटरफेस ऑफ b and c विल बी इक्वल टू f इंटू m3 डिवाइड बाई m1 प्लस m2 प्लस m3। ठीक है। सो दिस इज हाउ वी कैलकुलेट द फोर्स एट द इंटरफेस of the different combination of blocks, and the first step in solving these type of question is you have to find the, first of all you have to find the common acceleration। तो common acceleration क्या हो जाता है, applied force divided by the total mass, वो निकालने के बाद में then this is how we have to proceed further। So the force at the interface of B and C is equal to F dot M3 divided by M1 plus M2 plus M3। The force at the interface of A and B हो गया F ब्रैकेट में M2 plus M3 divided by M1 plus M2 plus M3 हो गया। ठीक है। The force consumed by the block A is equal to F dot M1 divided by M1 plus M2 plus M3। The force consumed by the block B will be equal to F dot M2 divided by M1 plus M2 plus M3। Now similarly the force consumed by the block C क्या होगा, this will be equal to, the force consumed by the block C will be equal to, this will be equal to what, this acceleration, that is F divided by m1 plus m2 plus m3 into m3। ठीक है। Or we can say that the force consumed by this block C will be equal to the force at the interface of B and C। ये देखो ये दोनों वैल्यूज बिल्कुल बराबर है. So this is all I have for this session, and in the next session, that in the session number 2, I will continue to discuss some other configuration of the system of blocks which are connected with each other, and we will be discussing their motions in different configurations. So thank you very much for joining this session, and I hope that you have understood what I have discussed in this lecture, and hope to see you soon. Bye.